All right, this is 5.8. We're using congruent triangles in 5.7, and now we're going to use the coordinate plane to help us do proofs. So this is called coordinate proofs, but it's pretty much the same stuff. You gonna take notes or? All right, so example 1. And this is going to be number 3 in the book. I'll just say number 3 so you can follow along. So I'll do some of these even ones, and then I'll let you do the odds here. So example 3 is write a triangle with leg lengths of 3 units and 2 units. So if I draw a coordinate plane, I want to draw these things in a way that's actually going to help me. Put that down. I'm going to send this out. All right. So I'm not going to draw a triangle that is a right triangle like this and then be like, okay, well, I got to get from this point to this point and make that 2 units. That makes it really difficult to figure out how to find those points. So I'm going to make a right triangle using vertical lines and horizontal lines the best I can. And I'm going to put it using the origin. So I have 2 units here and 3 units there, and make it just really simple to figure out. Okay? So we want to use vertical lines and horizontal lines. Any questions? If you use the origin, then do so. All right, so now let's do the next one, number 4. And it says it wants you to draw a square with the side lengths being 3 units. Again, don't make your square in a diagonal fashion. That doesn't really help you. Okay, you will have to use the distance formula. You will have to use the midpoint formula, and you will have to use the Pythagorean theorem. Those are things you're supposed to have memorized. But let's draw these and make them simple. So I'm going to draw this square using the x and y axis. So all of these are the same length. It's a square. They're right angles. Makes it easy to count the sides up and down and left and right. Okay? All right. Now these are 3 units long, so that's 3. This will be 3 up there. An isosceles right triangle, example 5. Sorry. I want to draw an isosceles triangle. I'm not going to draw an isosceles triangle like this. That doesn't help me. Again, try to use your axes. And it has to be a right triangle. So I'm going to draw a right triangle where the side lengths are the same using the x and y axis. Now the side lengths are length p, so from at this point this will be p0, and this one up here would be 0p. So a different abstract thought of how you go about doing this. You have to use algebra here. The side length of your isosceles triangle is going to be p units long. All right, we're going to do another one here in a minute that's a little bit different. Example 6. I'll draw these bigger here in a minute. Number 6. A scaling triangle with one side length of 2m. All right, so scaling, this isn't really helpful, but let's at least put one side length on the x-axis. So there's an example of a scaling triangle where it's easy to measure one of your side lengths. Even the other way, you could do it like this and say that this is 2m, and at least with this being on the x-axis, you could get the other side pretty easily. But this is getting you into what it is we're trying to accomplish here. When you get to trigonometry, we start to pull all this stuff together and say, how do you measure this? How do you get from here to here? How do you know how far away that is? Or other things that we do, sound waves and things like that. But you're also wanting to use what you've been taught to make it easier. What do you do in algebra when you start a problem? Don't you simplify? Okay, that's the same concept. Try to make everything easier before you start. All right, let's go on. Oops, can we do the whole thing here? Let's add a page. Yep.
Where?
On my iPad. Thank you. Oops. Add, come on. Another one. Okay, here we go. Get off the page.
You should break the purple.
Thank you. Purple one? Yeah, all right. So, we're almost done. Let's go to, this is number 8. This is going to be, I'm going to draw it on here.
I know you did not just do that.
Yes, I did. All right, so here we're going to have a picture. We're going to prove this information. So put a point at 1, 4.
Can I just, never mind.
As point H. Put a point at 6, 4.
Wait a minute, you're going really fast.
No, draw faster.
Okay.
And put points at 0, 0. And 5, 0. And this will be angle O and F. Now draw diagonals. And point G is in the middle. G is the midpoint given. Yep. G is the midpoint. So we want to prove that triangle GHJ is congruent to triangle GFO. No, that's right. GHJ and GFO. Okay. Okay, so we have G being the midpoint. What's that mean? It's the midpoint of HF.
So definition of
H to
midpoint.
G and GF.
So, yes, HG and GF are congruent because of the definition of midpoint.
Hey!
No, you cannot say OG is the same as GJ. There's nothing, it's not saying it's the midpoint of that segment. So you cannot say that. For instance, if I do this exact same thing, and I say this is the midpoint, and I draw this segment here, are you saying it's the midpoint of that other segment too? Okay, so there's nothing that says it's the midpoint of the other one. All right. What else do you know?
You know that,
You have vertical angles. HGJ is a vertical angle to FGO.
oh,
Where's the other side?
just kidding.
Okay? All right, so
Wait.
you could say that HJ is congruent to, or it's not congruent, is parallel to OF. Why?
That's what I was gonna say, but I don't know if that was right.
Why are they parallel?
Because
A theorem.
The formula. Well, we didn't do that.
What's the definition of parallel lines? What is the definition of parallel lines? How do you know two lines are parallel?
They're equal. They said,
no,
they look
they
the
never
same.
touch.
They don't touch.
Are you asking for like the?
Aren't the slopes the same?
Yeah.
Yeah, that's the definition of parallel lines. Slopes are the same. Aren't the slopes of those lines the same?
Yes.
They're horizontal, aren't they?
Mhm.
Yeah. So HJ and OF are parallel. Therefore, angle OFG is congruent to angle GHJ. Why? Alternate interior angles
Yeah.
theorem.
Ow.
And now you have
Sad.
Oh.
angle, side, angle.
Oh, yeah,
Now, many of you were going to say that these two sides were the same. And you were correct. They're the same distance. You could use the distance formula and say they're the same. But then you have angle side side, and we don't say angle side side. Okay?
Why is everyone like about it today?
All right. An isosceles triangle with a base length of 60 units and a height of 50. So we have an isosceles triangle. The base length is 60. The height is 50. So it says, place the figure in a coordinate plane and find the length of the other side. So we want to find the lengths of the isosceles part. So I'm going to put this into a coordinate plane. In a way that makes this easy to figure out what the side lengths are.
It's an isosceles, right?
It's an isosceles triangle. What do you know about the triangle I just drew?
180.
Two sides are equal.
That's right.
It's a right triangle. It's not a right triangle. I mean, there are two right triangles
Right angle
in
would
it.
be isosceles.
It's an equilateral.
So what is this length right here?
90 degrees.
Oh, what?
Oh.
Man.
And this is 50. Pythagorean theorem. A squared plus B squared equals
C squared.
C squared. And you'd have to figure that out.
Wait, what?
Okay? I'm not going to do it. You're supposed to be able to do that. Example 12. Last one.
Oh, we just did 10.
A square with side length n. Again, I'm going to draw a square like this. The side length is n. That means all the sides are n, right?
Yeah.
Okay. A square with side length n. Find the length of the diagonal. So if I cut it in half like this, it doesn't matter which diagonal you use. We'll call this C.
No, we couldn't do it.
Because now I have a right triangle. And I can use the Pythagorean theorem again. A squared plus B squared is equal to C squared. Your side length squared equals your hypotenuse squared.
Math.
Combine like terms. Don't you add your coefficients when you combine like terms? How do I get C from C squared?
You do square root.
Square root. So that's C. How'd you get C from C squared?
Because
The square root, right?
it's
Okay, well, what's the square root of n squared?
2n.
So if I break this down, it's the square root of 2 and the square root of n squared, right? I don't know what the square root of 2 is. So it's going to stay the square root of 2. But the square root of n squared is what? N. So the answer is n square root of 2.
This is like algebra. Hate algebra.
And that is how you do these. If I said, I'm going to just teach you something real quickly. If you have algebra 2, what's the square root of 25? Let me put another page up here. Square root of 25 is 5. Well, if you break it down, it's the square root of 5 and square root of 5, right? Which is really 5 squared, isn't it? There's a 2 out here. If it's not there, it's understood. If I did the square root of x to the 6th, that's the same thing as the square root of x cubed times the square root of x cubed, isn't it? Don't you add exponents when you multiply like bases, Algebra 1 students? So that's x to the 6th if I put those together. Well, these two are the same type of thing. So the square root of x to the 6 should just be x cubed. Here's the shortcut. Divide your exponents by that root. So 6 divided by 2 is 3. That's how you do your exponents. So if I said the square root of x to the 88th power, that should be x to the 44th, because 88 divided by 2 is 44. Anyway, you're supposed to know how to do that as algebra students, algebra 1 students. But that should help you when I say this, x to the 9th. What's the cube root of x to the 9th? X cubed. There's your algebra 2. All right, so here's your assignment, page